All right, it's almost 9, so let's get started. Good morning. First of all, thanks very much for coming so early in the morning, especially after the party night. I'm losing my voice a little bit, so sorry about that. I'll try to make it. So my name is Mete Atamel. I'm a developer advocate at Google. I'm based in London. This is my first time at NDC Oslo, and first time in Oslo as well. I went around the city a little bit in the last couple of days. I really like it. And hopefully I'll see more on the weekend. So today we're going to talk about building ASP.NET apps on Google Cloud. Before I start my talk, a little bit of information about myself. As I mentioned, I'm a developer advocate, so my role is basically to come to conferences like this, give talks about Google Cloud-related technologies. This is my Twitter. If you want the slides, I'm going to put the slides right after my talk on my Twitter, so just follow me if you want it. This is my email. I'm also around. We have a Google Cloud booth at the conference. So if you guys have any questions, feel free to stop by at the booth. We also have code labs at the booth where you can actually do some of the stuff that I'm going to show you today yourself using our laptops at the booth. And lastly, I have a talk feedback link. So I always like to hear your feedback about my talk. So if you have any feedback, feel free to fill that from that link. All right, so what are we going to talk about today? First, I want to do an intro because I like to answer the question of why you should even care about Google Cloud when it comes to ASP.NET applications, and answer some questions on that because people always ask me, I already have my stuff running in a data center or Azure. Why should I even invest in moving that to Google Cloud? And I think there's some good reasons, so hopefully we'll cover that there. Then I want to look at the traditional ASP.NET applications. So the traditional ASP.NET that runs on Windows, how can you take that and how can you move that to Google Cloud? What does that look like? So I'm just going to show you a simple example on my laptop, and then after that, we're going to move that to Google Cloud and see how that looks like. Moving an app to the cloud by itself is not that interesting because you are just running it in the cloud rather than somewhere else. But I think the power of cloud is basically all the services and the tools that becomes available to your application once you move it to cloud. So in the third part of my talk, I'm going to talk about cloud storage, PowerShell commandlets, machine learning with Vision API and Speech API. And we'll basically transform our application into something better by using the services and the tools that Google Cloud provides. So the idea here is to give you an idea of what kind of things that become available to you once you move your app to the cloud. And finally, we'll talk about the new containerized world, because as you guys know, ASP.NET is moving to ASP.NET Core, and ASP.NET Core runs on Linux, and with that, you can run it in Docker, and with that, you can run it everywhere. So what does that mean for Google Cloud? So if you have an ASP.NET Core application, how can you run that on Google Cloud? And the answer is App Engine and Kubernetes, so we'll briefly talk about that. I'll show you a demo on App Engine, but I don't think we'll have time for Kubernetes. I'll just mention what it is, and if you want to hear more, feel free to stop by at the booth, and I'll talk more. By the way, I'm sorry for these guys that are sitting here, because I usually ignore my left side. I'll try to turn around once in a while, but if I don't, sorry about that. All right, so let's do the intro. I guess the first question you have right now is, Windows Server, SQL Server, ASP.NET on Google Cloud? Really? Like, what's happening? Because Google is known for search, for maps, for machine learning. But when it comes to .NET development, it's like you don't hear about Google too much up until recently. And I think you're right to think that way, because if you look at the world that we used to live, back in 2014, we used to have like kind of two worlds, right? On one side, we had the Linux open source world with the tools and languages around that. And then on the other side, we had the Windows world. So instead of Java and Python, and we had C#, instead of Bash, you have PowerShell. Instead of MySQL, you have SQL Server. And for me, the most annoying part of this split is that these two worlds, they kind of existed together, but they didn't really interact. So I started my career on the Windows side, and I learned all the tools and tricks of Windows, but then at some point, I had to move to the Linux side because I switched my job. So I had to relearn everything, even though I was trying to solve similar problems. And then at some point, I started working for Microsoft, so I came back to the Windows side. So doing this back and forth was really tiring, and there was no really good reason for that. And Google was mostly on the Linux world, and that's what we use internally. But since then, things are changing. So the first thing was the .NET going open source in 2014. Then after that, we started seeing gradually tools and languages moving from Linux to Windows and Windows to Linux. So OpenSSH moved from Linux to Windows. Then we had Ubuntu and Debian, the Linux operating systems running on Azure, the Microsoft Cloud Platform. Then 2016 really accelerated things. So SQL Server, the flagship SQL server of Microsoft, started working on Linux. The PowerShell scripting language of Windows started working on Linux. Then we had Bash or Linux coming to Windows. And then the year ended with 2 announcements in 2016. The first one, and then we had ASP.NET Core. Of course, now you can have ASP.NET running on Linux, Mac, and Windows. And this was big news for me because now all the time and effort you spend in learning C# and ASP.NET, now you can use that on Linux as well, which is great. And then the year ended with 2 announcements. Microsoft joined the Linux Foundation, and then Google, because of our work with Google Cloud Platform supporting .NET, joined the .NET Foundation. So it was, I think, a great couple of years that changed pretty much everything in the .NET world. So what we have today is we still have the 2 operating systems, but the tools and languages around them, they're converging, they're coming together. And that's great news. Basically, it's a great time to be a .NET developer. I used to do Java before, and at some point I switched to C#. And I never miss Java anymore because C# has everything Java has and even more, I think. But one thing that was missing was the cross-platform support. So I was always bothered by the fact that, I can write C#, it's great, but it only works on Windows. And now that changed. So for me, there's no reason to go back, and I'm really happy about that. And at Google Cloud, we are basically trying to support .NET as one of the main languages on our platform, along with Java, PHP, Python, stuff like that. All right, so now let's answer why deploy to Google Cloud as a consumer. Because as a consumer, you have choice when it comes to cloud providers. So why should we even care about Google Cloud? I think it boils down to 3 main points. The first one is the Google's infrastructure. So when you're running in Google Cloud, you're running in Google's own private network. So even when you have services in 2 data centers, they are not going through the internet. When you're communicating, they're not going through the internet. They're using Google's own private network, Google's own fiber optic. And actually, Google is like laying down fiber optic down Pacific to make sure that that private network is private. And the reason why we do that is because when we own the whole network, we can control latency, and things are much more stable than going through the internet. Our VMs are really fast, so you can provision VMs within seconds if it's Linux. With Windows, it's a little bit slower, but it's still quite fast. And because of fast VM provisioning, autoscale just works. So when you need to autoscale, it just scales really fast up, and then it scales down really fast. So the infrastructure is really good. The second thing is price. Obviously, we all care about the price. We want things to be as cheap as possible for competitive reasons. So the base price at Google is as competitive as it can be. But we also build features to make it even cheaper for everyone. For example, if you run a VM, virtual machine in Google Cloud, we charge per minute. So if you use a virtual machine for 10 minutes, you get charged 10 minutes. You don't get charged for the whole hour. If you use a VM for the whole month, then you get 30% discount by default. You don't have to do anything, you just get that. And the last one, the sizing recommendation. So if you use a VM, and let's say that VM is a big instance, we detect your usage pattern of that VM, and we recommend you. We tell you that VM is actually too big for your load. You can actually downsize that to a smaller VM and save money. So once in a while, when you open the console, you see that there's a recommendation from Google saying that, why don't you downsize this because you don't need it. So because of all these features, and there's more, the price ends up being really competitive compared to other places. And also flexibility. So if you want a virtual machine with lots of memory, but not so much CPU, you can actually customize and get that. Or if you want a VM with a lot of CPU, but not so much memory, you can also say, this is how much CPU I want, this is how much memory I want, and you only pay for what you use. So you don't have to get a big machine with lots of CPU and memory just because you need memory, right? So you can customize everything and get custom VMs. And there's something called preemptible VMs. So let's say you have some work to do, but you don't care how many VMs you have. You can use 5 VMs or 10 VMs, it doesn't really matter. In that case, you can use what's called preemptible VMs. So these are VMs that are given to you, but they can be taken away from you at any time. Because of that flexibility, they are almost 80% cheaper than normal VMs. So if you can use preemptible VMs, it becomes even cheaper. So basically, in terms of a consumer, it comes down to the infrastructure, price, and the flexibility that you get with Google. Now, as a developer, why should you deploy to Google Cloud? Again, I think there's like 3 separate buckets for this. The first one is the options that you have. So if you want to use VMs, you have Compute Engine. If you made the switch to containers, there's Container Engine and Kubernetes hosted in Container Engine. If you don't care about containers or VMs, you just want to deploy your app and let Google auto-scale it for you and run it in production for you, then there's App Engine. And then if you just want to work with functions, not even care about applications, there's Cloud Functions. I'm going to show Compute Engine today, and I'm going to show App Engine today, but I won't show Container Engine because that involves Kubernetes, and that's a whole different topic. But I'll be happy to show you that in our booth. So you have all the full range of options you have when it comes to deployment. The second thing is once your app is in the cloud, we have lots of services. But the key differentiator with our services is that we try to make them as managed as possible. So what that means is that when you're using, for example, PubSub, the messaging platform, you create a topic, and that topic is globally available everywhere, and you can send messages and you can receive messages from the topic, but everything is managed. You don't care, you don't have machines, you don't have clusters to worry about. Everything is automatically globally available. And as load increases, things are added to the cluster and removed from cluster, but that's all abstracted away from you, so you don't have to worry about machines. Same thing with BigQuery. It's like a data warehousing solution where you can ingest your data, and then you can query the terabytes of data within seconds. So there, you just point to your data, it reads your data, and then when you send a query, it will basically use thousands of machines to parallelize the query and get the result back to you. But then again, you're not worrying about the cluster of machines. You don't have to provision things. Everything just automatically scales up and down as you need them. And then the last thing is machine learning. Machine learning is big, and it's becoming even bigger. And what we are trying to do is basically we have all these trained machine learning models that we've trained at Google with the data that we have. So we are making these available to people. So there's Vision API for image recognition. There's Speech API for speech recognition, and things like that. And we'll keep adding more and more APIs to make our models available to you. And then if you want to build your own model with your own data, there's TensorFlow, which is an open source machine learning framework. And we host that on something called Cloud Machine Learning so that you can run TensorFlow models at scale on Google Cloud. All right, so this is the last slide that I will cover, and then I'll start showing you some code. So when it comes to ASP.NET deployment, you have basically kind of 2 worlds in Google Cloud. The first world is ASP.NET on Windows. So if you're using the traditional ASP.NET applications on Windows, you can run that on Compute Engine. So in Compute Engine, you basically get a VM with Windows Server, and you have different versions of Windows servers that you can get, and then you can also get ASP.NET Framework installed on that Compute Engine instance, and then you can deploy your application using Visual Studio. And I'll show you an example of this in the demo shortly. If you switch from ASP.NET to ASP.NET Core, you can containerize that using Docker, and then you can run it on either App Engine or you can run it on Kubernetes on Container Engine. So App Engine is the easiest way to run your containerized ASP.NET Core, and that's the one that I'm going to show. So the idea with App Engine is that you just pass in your container and you just say, just run this at scale. I don't care where you run it. I don't care how many machines you want to use. Just make it work. And by default, you get things like dashboards and versioning and traffic splitting that I'll show you. So it's easiest way of starting, but then sometimes you need to control your cluster or containers. You want to be able to specify how many containers you need and things like that. So for those use cases, then Kubernetes makes more sense. So you can use Kubernetes hosted on Google Cloud on Container Engine. All right, and then this is the last one, I promise. And then once you have your app, you probably are using something like SQL Server, so you can get SQL Server on Compute Engine. We also have something called Cloud SQL, which is manage MySQL and manage Postgres as well. So these are like SQL manage Postgres and MySQL managed by Google. We will probably have SQL Server managed at some point as well, but today you have to deploy that yourself. And then in terms of tools, there's a Visual Studio plugin that you can install that helps you to manage your Google Cloud resources that I'll show. There's a lot of libraries. So for every Google service, there's a .NET library. It's their own NuGet, and we'll use some of those in the demos shortly. And then there's even PowerShell commandlets. So there's a lot of different commandlets to script your access to Google Cloud. So we are basically trying to cover everything, and we are adding more and more. So no matter what you want to do, we will try to cover it. If there's something missing here, let me know after the talk. I'll be happy to chat to you about these and see what else we need to add here. Because we really want to support .NET and C# as much as possible on Google Cloud. All right. So now let's talk about moving your existing ASP.NET applications to Google Cloud and see how that looks like. And to do this, I'm going to, so as I mentioned, to move existing apps, you would use Compute Engine. So we'll go through that and we'll see how to get a Windows server on Compute Engine and how to deploy it from Visual Studio. And to do this, I'm going to use Contoso University application. People know this application? Some of you know, maybe? Yeah, it's a reference application. It's about this like fictional university that has students and courses and classes and departments. And it's an MVC5 application. It's using SQL Server as the backend. It's very simple, but it shows like the basics of MVC. So first, I will run that application locally so that you know how it works. And then after that, I want to move that app to the cloud and see how the process looks like. So that's the idea about this. So let's take a look at this app. I have Visual Studio open here. And let me just run it first and see how it works. All right, so this is the app, and we have students. And we have details about the students, the first name, last name, enrollment, and the courses the student is taking. And then you can edit a student, make changes, save it, and it's backed by SQL Server. Then we have courses. And we have instructors. So it's very, very basic with some very basic views of the app. Let's take a look at the code briefly. So it's an MVC application. So we have models. So for models, we have a person object, and then we have a student that extends from the person, that adds some things to the person, like enrollment date. Then we have courses. So we have basically a model for everything on the page. Then for each model, we have a controller. So course controller, instructor controller, student controller. So if you look at the student controller, it's basically the typical controller you expect. So there's a controller for getting the details of a student. There's another method for creating and things like that. And if you look at web.config, right now I'm using the local DB, so it's the local SQL server running on my machine, right? So this is the app. It's very simple, but we'll use this as a reference app to move to Google Cloud. So let me just go back to my presentation. All right, so now we want to move this to Google Cloud. So what do we need to do? First, I want to install Google Cloud Tools for Visual Studio. This is an extension that you can install in Visual Studio, and it makes it really easy to manage your project, Google Cloud project, and push your application to Google Cloud. Once we have that, first I need to get a Windows Server VM with ASP.NET Framework installed. So I'll do that on Compute Engine, and we'll see how that works. And then I also need a SQL Server running in Google Cloud, so we'll get one. And then finally, I'll publish from Visual Studio to Google Cloud directly from Visual Studio. So let's take a look how that works. So here I am. To get the plugin, I go to Tools, and then here, Extensions and Updates. And then if you go online and search for Google Cloud, it shows up with this Google Cloud Tools for Visual Studio. I already have it installed here, so I won't install it, but then you can just double-click and get it installed. So once it's installed, if you go to Tools, and under there's a Google Cloud Tools, and you need to first add your Google Cloud account, so that Visual Studio can talk to your projects. So you do Manage Accounts and Add Account. This opens up a new page. You can select your account. So this is my development account. I'll choose that. And it's asking me, do I want to authenticate Visual Studio? Yes. And now I'm authenticated with Visual Studio, so you can close this. And then if I go back here, it's telling me that my account already exists because I already have this here, so that's fine. So once you're authenticated, if you go to Tools and Google Cloud Tools again, there's something called Google Cloud Explorer. So in here, this is my account that I'm already logged in. These are all my projects in Google Cloud that I can select. So I'm going to select my .NET project. And then under here, you can see a few things. So you can see my App Engine applications. So if you look here, I have like 2 versions of my application and they're like 50%, 50%, so they're getting half of the traffic each. I'll show this app later. And then I can see Compute Engine instances. So these are VMs that I have running in the cloud already. So as you can see, I already set up the Contoso VM and then the SQL server, so I can see them here. And then you can see your cloud storage. So these are buckets where you can save your data, any kind of data. And then Cloud SQL. So these are MySQL instances or Postgres instances that are managed for you. I don't have any, but you can see them if there were. And we're going to be adding more and more stuff here. So eventually, you should be able to see all your resources from Visual Studio. We just released this probably like 6 months ago, but we'll keep adding more to it. So now the first thing I need is a Windows Server VM in the cloud. So to get that, I can come here to Compute Engine, right-click, and say New ASP.NET Instance. So this opens up what's called, I have to authenticate. This opens up Cloud Launcher. Cloud Launcher is like a marketplace. So I have to switch my account, 1 sec. Cloud Launcher is like a marketplace for different solutions. And one of those solutions is called ASP.NET Framework. So with this, if I click on Launch on Compute Engine, this will basically give me a Windows server with ASP.NET Framework already installed. So all I need to do is give my deployment a name. So I'll just call this ASP.NET NDC Oslo. Then I can choose my zone. So we are in Europe. So let's just say we'll choose Europe West. Then I can choose my machine type. So let's just get a good machine, like 4 CPUs. I can choose my Windows Server version. So 2008, 12, 16. I like the latest stuff, so I'll choose 2016. Your persistent disk and your HTTPS traffic. So if I hit deploy, now within a few minutes, I'll have a Windows Server with ASP.NET Framework already installed. So we won't wait for this because we don't have time, but let's also get a SQL Server instance. So to do that, I go back to Visual Studio, and then this time, instead of choosing an ASP.NET instance, I'm going to choose a new instance. So this will open Cloud Launcher again, and I have to switch my project again. That's what happens when you have multiple accounts. All right, so it opens up the page for me to get a SQL Server. And what I want to do is I want to call this instance SQL Server NDC Oslo. Oh. Yep, and then I'll choose my zone again to, let's choose Europe West B. So what I need to do is right now the boot disk is Linux. I don't want a Linux operating system here. I want an application SQL Server. So I choose application images. And here I have all the different SQL Server instances, the versions that you can deploy. So what I'm going to do is I'm going to choose SQL Server 2016. And let's choose the enterprise version. Select. And then I can keep the rest as default and create. And this will give me a SQL Server. So with this, I will have a Windows Server with ASP.NET Framework and a SQL Server. And then this is the list of VMs that I already have. So I already have SQL Server installed and configured, and I already have a Windows VM already installed. So let's just try to deploy to one of those as these are becoming available. So this is my app. So to deploy to my instance, what I need to do is right-click, and then there's a Publish to Google Cloud place. So I choose that. Now, as you can see, I can publish to App Engine, Container Engine, and Compute Engine. This is a traditional ASP.NET application, so it knows that the only place I can install is Compute Engine, so it's showing me that one. I choose that. All right, and then this is the instance that I want to deploy to, VM. I choose that one. This is my account. And one thing I need to do, actually, before I do this, is I need to change this local DB to, and I need to use the SQL Server in the cloud. Right, so this IP is the IP of my SQL Server in the cloud. So now I can publish. Choose Compute Engine. and then choose this one, and then publish. And then will wrap my application and send it over, and within like a couple of minutes, I should have my app running in the cloud, talking to a SQL server in the cloud itself. Okay, well, yeah, there you go, it's there. And let's see that it works. So if I hit students, I have students, and this is all in the cloud now. So that's all it takes to move your app to the cloud. So let's talk about other stuff now. And as you can see, things are coming up here, but I can close this, close that. All right, now our app is in the cloud. It's great, but I want to add more stuff to it, right? So what I want to do is first, the students, they don't have any pictures, so I want to add pictures for them, but you need to save pictures somewhere. So there's something called Google Cloud Storage. That's basically for saving any kind of files you want. So you create a bucket, and you can save files in there. So what I'm going to do is I'm going to use Cloud Storage to save student pictures and then link them to student profiles. So saving student pictures one by one, it takes a while. So I'm going to use our PowerShell commandlets to bulk upload my images to the cloud. So we'll see how that works. So now students can send pictures, any kind of pictures, but that's not good. I want to make sure that these pictures are safe, so they're not violent or adult pictures. To do that, I'm going to use Vision API. So in Vision API, you can pass in an image, and it gives you a lot of information about the image using machine learning. So one of the things that it does is that it tells you basically if the image is violent, if the image is adult, stuff like that. So I'm going to use Vision API service to figure out if the image is safe and let people upload pictures only if it's safe. And then the last thing I want to add is I want to add like a fun facts about the student, but I want students to be able to talk to it. So I want to use Speech API, and student will talk, and then it will send it to Google Cloud. It will analyze it, and then get the text back, and then we'll set it as fun facts. So I'm trying to use some of the machine learning to see if it's easy or not. So let's do that. So let's look at the profile pictures first. So what I did is that I created a service called Image Uploader. So this is the class that I'm going to use to upload my images. So one thing that you'll realize in this image uploader is that it's using Google Cloud Storage. So this is a NuGet package that you can install that will give you access to Google Cloud Storage. So once I have that, what I need to do is so you always save your pictures or files to a bucket. So I have a bucket name that I pass into my class. Then after that, I get a storage client. So this is the main client that you use to upload images to or any kind of files to cloud storage. And then I have a method called upload image, which takes an image and an ID, and then it will just use the storage client. And then there's an upload object async method that you can call. And you basically pass in the bucket name, the ID, and then your image. And you can also specify how this image should be stored. So I want the image to be publicly available, so I make it publicly readable by passing this. And I also have a delete uploaded image, because when a student is deleted, I want to go to cloud storage and delete the picture of the student as well. So to do that, I basically just pass in the ID, and then from storage client, I just call delete object async, and this will delete the picture. So if you look at how I use this, I use this from student controller. So in student controller, when we create a student, we check if the student has an image, and if so, we use the image uploader to upload the image with the student ID, and then that gives me an image path, and then I set that path to the student model itself, and then with that I can display the image. So that's all there is to it. So all you need to do is basically install the NuGet package for cloud storage and just use it with straightforward APIs, and then you have access to it. So let's try it out. So I will run this. So I'll just try to add myself as a student. Create new. Last name Atamel, Mete, and then let's say I enrolled at the beginning of this year. And then let's choose a file. So I'll choose one of my images. and then great. And now this is uploading the image and then saving the student. So if I look at my page, you can see that I have a profile picture now. And if we go back to Google Cloud Console, here, here there's a storage area. So let's take a look, Google Cloud Storage. And then you can see I have a bunch of buckets, but one of them is called Contoso. This is for my app. And under here, you can see that my image is already uploaded. So it's already there. Cool, this is great, but then doing this one by one for every student is going to take a long time. So I'm going to use the PowerShell commandlets to kind of do this image upload in bulk. So when you install, there's something called Google Cloud SDK that you can install on your machine. And when you install that, it comes with something called Cloud Shell. I'll actually show you that. Yeah, so it comes with Google Cloud Shell, and then here there's something called gcloud that you can use to basically talk to Google Cloud from the command line. And the other thing that comes with this SDK is the PowerShell commandlets. So these commandlets, they help you to script in PowerShell. So what I'm going to do is I'm going to write a script. Actually, I already have a script. I just want to show you. So I have this script. It's in PowerShell. And what I'm doing is I'm specifying a bucket, and I'm specifying a folder. And I'm using this commandlet. So this is new GCS object. This refers to Google Cloud Storage. So I'm basically creating a new Google Cloud Storage object, and then I pass in my bucket. So this is the bucket that I have in Google Cloud. And then I'm passing the folder. So this is the folder I have locally on my machine. And then I'm saying that I want this to be publicly readable. So I'm basically taking my bucket and sending it to Google Cloud. That's what all this script does. So if we run this PowerShell script, we should see that it will look into the folder and it will upload these images. And now I can use these images from the student profiles. And there's lots of different commandlets for different kinds of things. So this is just one of them. But there's pretty much everything you can do in Google Cloud, you can use it from PowerShell commandlets. And if we actually come back here and do a refresh, you can see that my folder is here, and then I can update my students to use these pictures. All right, so that's that. Now the next thing I want to look at is, remember, like you can now send any kind of picture to Google Cloud, and that's not safe. So let's try to make it safer. To do that, we're going to use Vision API, which is a trained machine learning API that's already available to you. You just need to call and use it. So to use that, what I need to do is first, I created a new service called Image Safety Checker. So this class will basically, given an image, it will determine if the image is safe or not. But to do that, what we are doing is we are using a NuGet package, Google Cloud Vision API. So this is available on NuGet. And I create an image annotator client. So this is a client that you use to talk to Vision API. And then I have one method called isSafe. So this method takes in a picture, and then it passes the picture to the image annotator client. And then this will return an annotation. And this annotation has a number of fields to it. So one of them is adult, the other one is violence, the other one is spoof, and the other one is medical. So what I'm checking here is that, and these annotations, they are enums. So the possible values are likely, very likely, possible, unlikely, and very unlikely. So I'm checking whether this image is adult image, and the likelihood is less than possible. So it's not adult image, basically. And then I check it for violence, for spoof, and for medical. So if all of them are not likely, then I conclude that the image is safe, and I let the person to upload it. So if you look at how this class is used, I created a new version. So this image uploader, remember we used this image uploader class before? I created a new version called Safe Image Uploader. So this one, it basically just extends from image uploader. But then what it does is when the image is uploaded, it uses the image safety checker and checks whether the image is safe. And if it's not safe, it throws an exception. If it's safe, then it basically uploads it, right? So that's all there is to it. Let's take a look and see if this works. So here I am, and what I'm going to do is I'm going to edit my picture. and I'm going to choose another image. So this image is a guy, I don't know if you guys can see that, but it's a guy shooting, basically. So it's a violent image, and we don't like that. So let's see if our Vision API can detect that. So when I hit save, now I'm sending the image to Vision API. Yeah, see, like now it says, am I able to save changes? Because I sent the image to Vision API, and then Vision API detected that it's not safe, and then it didn't let me upload it, basically. So that's cool. And then the last thing I want to do is the fun facts. So these fun facts, I want it to be something where you can speak to it, and it will detect your voice and use that as fun facts. So to do that, I'm going to use something called Speech API. Again, I created another service, well, a couple of services. One is called Voice Recorder. There's nothing fancy here. The voice recorder basically records your voice. So there's a method called record from microphone, and you pass in some seconds. So you pass in, like, say, 3 seconds. It will record your voice and save to a file. So there's nothing fancy here. It's just the utility class. But then the voice recognizer is the one that actually does the work. So if you look at voice recognizer, again, it's using this NuGet package from Google Cloud called Google Cloud Speech. And then just like before, we create a client. So this time the client is called Speech Client. And then we have a method called Recognize. So what this does is that we call Speech Client, and then we pass in our file. So this is the file of our voice. And then we pass in some configuration for the speech. So I think these are the defaults. I'll just keep it as it is. And then what happens is that we send the image to Google, the file to Google Cloud, and then Google will do some analysis, and it will return some results. So it doesn't return just one result. It returns a number of results with some percentage of what it thinks is you are saying. And then also some alternatives as well. So some alternate text for the things that it returns. But what I'm doing here is that I'm basically going through the results and alternatives, and I'm returning the first one. Normally, you would basically look at the ones that have the highest rating and use that one. But basically, it's just one call to speech client, and then you get the results, and then you can use them as you wish. So let's see if this works. So here I am. Let me choose another image, make sure that we can save this. And then when I hit record now, it will try to detect my voice, and then it will send it to Google Cloud, and then we will get a text back, and then we'll see what we get back. What should I say? Let's say, hello from Oslo. Oh, it didn't work. Let's try one more time. Hello from Oslo. Something's not right. Maybe I'll go back. Try one last time. It's always tricky with the microphone. Hello from Oslo. Oh, it says slow. Okay, sorry. But it does work pretty well, usually, without the microphone. Cool. All right, so we went through these. Yep. Now I want to talk about the actual new world, the containerized world. So as you know, ASP.NET Core now runs on Linux. And then what that means is that you can create an ASP.NET Core app, and you can wrap that into a Docker container and run it into a Docker image, and then run that in a Docker container. And then you can take that Docker container, and you can either deploy it to App Engine, or you can deploy it to Kubernetes or Container Engine on Google Cloud. So that's how you would run the new containerized ASP.NET Core applications on Google Cloud. I still get this question on, like, why should we even bother with containers? So I just want to answer it here briefly. If you look at how we used to deploy apps, it was pretty much like this. We used to have a physical machine, and then on top of that we had an operating system. Then on top of that we had a common set of libraries, and then we would deploy our apps on top of those libraries. The problem in this case was that there was tight coupling between apps and libraries and the operating system. So anytime you change something with the operating system, or anytime you change something with the libraries, you could potentially break any of these applications. Now later we got virtual machines. So the idea with virtual machines is that you have a single physical machine, but you have multiple operating systems virtualized. So you would basically virtualize the operating system, the libraries, and the app in a virtual machine. The good thing here is the complete isolation. So whatever you change here is not going to affect something in here. But the bad thing is that instead of dealing with one operating system, now we are dealing with 4 operating systems and 4 set of libraries. So it was very heavyweight, and these virtual machines, they're not so easy to create, they're not so easy to start. So we would normally do them at the end of our development cycle. When we're ready to ship our application, we'll put it in a virtual machine. But we wouldn't really use it on a day-to-day basis as we develop software. Now, with containers, we are trying to basically combine the best of both worlds. So in containers, you have a single machine and a single operating system, and you're virtualizing up from the libraries, the dependencies of your app, and the app itself. And the containers they're really lightweight, they're really easy to start, and you still have the isolation that you need for your applications. So you have the isolation, but you don't have the heavyweight of operating systems. So that's why containers are kind of great. So what is a container? It's a lightweight way of virtualizing your applications, basically. And as I mentioned, they're isolated and sealed, so you can have multiple containers running on a single operating system, and they don't step on each other because they're isolated from each other. They're very easy to deploy. It takes like 2 seconds to deploy. They're very easy to introspect, so you can actually SSH into the container. You can see what's running. You can see the logs. So it's not a black box. You can actually get in there and see what's happening. And for me, the biggest part is it's composable. So you can actually have a base image that you depend on. So that's your dependency. And you build your image on top of it. And you can layer your dependencies. So if someone depends on your image, they can actually take your image and layer their image on top of it. This way, your dependencies are all layered. And whatever you need, you can keep. Whatever you don't need, you can take out. So it makes it really easy to containerize and put things together, all your dependencies. So Docker is the main container platform that people use nowadays, but there are others. There's something called Rocket from CoreOS. That's also a container platform that people end up using. So when it comes to Google Cloud, as I mentioned, you have 2 choices when it comes to containers, containerized ASP.NET applications, App Engine and Container Engine. So we'll talk about the App Engine. I'm going to show you how to deploy that to a simple app to App Engine. So App Engine is that it's a way of like giving your container to Google Cloud and letting Google figure out how to run it at scale. So you just basically create your container, give it to App Engine, and then it will start with 2 machines, but then it will auto scale as it needs to, and it will downscale as it needs to. By default, you get some dashboards that I'll show you. You get versioning, so you can deploy multiple versions of your application. And then you can split traffic between them. So you can say 50% gets the traffic, and the other 50%, the other version gets the other 50%. So it gives you some like default features, and it's really easy to basically deploy to App Engine. So it's a good way of getting started. And also auto scaling, as I mentioned, it automatically scales, so you don't have to worry about that. So let me show you how that works. So here I am in Visual Studio again. So when you install the Google Cloud tools for Visual Studio, you get some templates. So if you go to File, New, Project, under C#, you'll see Google Cloud Platform. And we have some templates for traditional ASP.NET MVC and then the ASP.NET Core as well. So I chose this ASP.NET Core MVC, and I created like a simple MVC app. So I already have it here. So this is the app. And then in your app, there's an app settings file. So this file basically it defines your app to Google Cloud. So here I'm specifying my project ID, and I'm specifying my service name and version. So once you set these up, all you need to do to deploy this to Google Cloud is right-click and then say Publish to Google Cloud. And this time, since this is an ASP.NET Core application, it's not giving me an option for Compute Engine because you wouldn't really deploy it to Compute Engine. It's giving me an option for Flex, App Engine Flex, or Container Engine. So if you have a Kubernetes cluster already set up, then you can click this and deploy it there. Or if you want to use App Engine, you can choose that. So I'll choose that. And you can give your version a name. So I'm going to call this like version, let's say version NDC. And then promote version means once this is deployed, should it get all the traffic or not? I don't want it to get traffic because I want the old version to get the traffic. And then I will test this out and then make sure that it works, and then I will promote it myself. And then this says, should I open the site after publishing? No, I don't need that. So if I hit publish, email version. OK, so let's call it something else. Let's say version 2. All right, so what's happening right now is that it will basically take your code, and it will send it to Google Cloud. In Google Cloud, we'll create a container out of it, so you don't have to create the container yourself. And then we'll host it on Google Container Repository. So it's a place where you can actually host your container images. And then from there, we'll publish it to App Engine. So that's how it works. So it will take your code, containerize it in the cloud, put it somewhere in the cloud so you can use it in different places. And then from there, we'll pull it to App Engine Flex. I already have a version, so I just want to show you the version that I have. So if you go here and under App Engine here, so by default, you get some dashboards. As you can see, I have 2 versions, version 0 and version 1. And then you have dashboards for latency, traffic, memory usage, stuff like that. I mean, I just deployed these apps, so I don't have any charts yet. But if you are using for a while, you can see all these charts for like an hour, 6 hours, 12 hours. So this is automatically done. You don't have to do any work for this. It just works. Under services, you can see the different versions you have. So I have version 0 and version 1. They each are getting 50% of the traffic. If I want to change that, I can split the traffic, and I can say, OK, I want this guy to get 90% of the traffic, and the other one gets 10%, and hit save. And this will change the traffic settings. And then hopefully it will update, yes. And if you go back here, you can see that my traffic is split that way. And there's more stuff here. There's like services. So in App Engine, you can have a default service, but you can also have microservices. So you can define like multiple services in here and manage them within a single app. So you can have multiple small microservices managed by App Engine. So this gives you an idea of how it works. Let's see if I have time. Yes, I have some time. And the last thing I want to talk about is Kubernetes. So App Engine is nice and it's easy to use, but it doesn't really give you much control. So all you have is basically services that you can define, but you can't really do much else. If you want to create your own container cluster, then Kubernetes is a good choice. So Kubernetes, it's a Greek word for a governor. Actually, the right way of saying Kubernetes is Kubernetes. That's the Greek way of saying it. But it started in the US, and everyone started calling it Kubernetes, and now everyone calls it wrong. But it's Kubernetes, actually. And it's an 100% open source project. It's written in Go, and it's supported by all these big companies like Google, Red Hat, IBM. Even Microsoft is contributing to it with Windows containers. So there's a lot of support for Kubernetes. The great thing about Kubernetes is that it supports multiple cloud providers. So you can have a Kubernetes cluster running in Google Cloud. You can have it running in Azure. You can have it running in AWS. You can even have a Kubernetes cluster that spans clouds. So you can have a cluster in Google Cloud, another cluster in AWS, and you can federate them into a single cluster, basically, which is great. Even though it's open source, it came from something called Borg. So Google has been running containers for a long time, for 12 years, and we have this internal container management platform called Borg. So people who worked on Borg, they basically learned from it over the 10 years, and they created Kubernetes for the open source world, so people can use similar things that we use at Google at Borg. So because of that, it's very mature, even though it's open source. Like from version 1, it was really mature and stable. All right, and at the high level, this is basically what you have in Kubernetes. There's a master that kind of manages the cluster, and then there are nodes where you schedule containers. And the master and the nodes, they talk through something called kubelets. So these are like small, basically daemons that run on each node that manage the communication between the master and the nodes. And as a user, you talk to the master through the Kubernetes API, and there's also a CLI and UI as well. And if you want to use Kubernetes, I mean, you can run Kubernetes anywhere. You can even set it up in your own infrastructure. But if you want to run it on Google Cloud, this is kind of how it looks like. So what you do is you use something, you use something called Cloud Shell to build your application in the cloud. You create a Docker image, and then once you have that image, you push that to a registry. So in this case, you can use Google Container Registry. And once your image is hosted there, you use gcloud to get a cluster. So with one command, you say basically, I want to create a Kubernetes cluster. I want to have this many nodes to schedule containers. And I want these machines to be this size. So with just one command, once you have the cluster, then you can use kubectl. This is a command line tool to manage Kubernetes. And you can basically say, create me a deployment and use this image. And Kubernetes will figure out basically how to pull that image and schedule it on some of the nodes that you have available. I actually have a whole talk on Kubernetes and ASP.NET Core. It's like an hour. So that's why I'm not talking about it here. And I actually show all of this there. If you're interested, let me know. And I can send you the link to that talk and on slides as well. But it's a whole different topic. And Kubernetes has a lot of constructs like pods and volumes and services and all sorts of things that you need to know about before you can be productive. But it's very useful because it's basically a whole platform to manage containers in production. All right, so let's do a summary. Basically, we started with an ASP.NET application running locally. We moved it to Windows Server and SQL Server running on Compute Engine in Google Cloud. Then we added pictures and saved them to cloud storage. And we added some intelligence with machine learning APIs. And we tried the new containerized ASP.NET Core with App Engine. And then we briefly talked about Kubernetes and Google Container Engine. If you want to know more, these are the links. So this is the main page for .NET stuff at Google and for Windows as well. Then this is the page for App Engine and for Container Engine. This is the page for Kubernetes. And this is my information. I'm going to put the slides right after this talk. And if you have any feedback about my talk, that's the link. Thanks very much.